So today we will be looking at the npm package Chalk. I believe it's one of the most downloaded packages on a weekly basis. And for those of you who are not familiar with it, Chalk is used for styling console logs. What do I mean by that? If you look at the npm readme documentation for Chalk, you can see all this text that you would normally console log, and that would come out in kind of default white text color on the black background. You can stylize that text. And how does this happen? Let's quickly jump into our node console to look at that. So typically what we would do is we would say console log and whatever text that we have, in this case ABC. But what if I wanted my text to look green in color, right? So I'll go ahead and type in something like this, right? So you see now whatever I printed is green. So what is this unique string at the start that I have appended in addition to what I wanted to output, right? So this is called Ansi escape codes. So Ansi escape codes, to summarize them, they are a set of instructions that convey a special meaning to a terminal emulator. So when my terminal emulator saw this specific string, it did not interpret it as an actual string and try to, log it out. Instead, it thought of it as us instructing the terminal to output whatever text that we have after it in green color, right? Similarly, we can do something similar to change the background color also, right? So now you see, in addition to just having the green color for the text, we also have the blue color for the background, right? So these are the functionalities that are offered to us using ANSI escape codes, right? So just to quickly go over how this is happening. So 32 is green foreground color or the green text color, whereas 44 is saying that I want the blue background color. And after that, that is applied to ABC. And towards the end, all I'm saying is I want to reset my colors, or you can think of as style, right? If you go into the wiki documentation, you will see this table where they have this 3-bit and 4-bit numeric representation of different colors. So as you can see, 32 corresponds to green when you look at FG, which stands for foreground, whereas 44 corresponds to blue when we look at the background, right? So now we will look at if you wanted to do something similar but using code, right? If you wanted to create a package that helped us do something similar, how we would go about doing that. So for that, I've created this new repository called supercolor using our TypeScript boilerplate, and we are on this new branch which does not have any code as of now. So let's dive right into it. So before diving into the code itself, let's think of what are the things I actually want to achieve, right? So, and before even doing that, let's actually look at how Chalk API is structured, right? So as you can look in its README documentation, Chalk has these different functions or methods that you can call uh, on its imported API that help you stylize the text according to that. So as you can see, we have chalk.blue.bgred, which is like background red.bold, which is going to apply all these three styles onto hello world, right? So that's how the normal Chalk API is structured, right? So if you see it's chalk.style, and you can concatenate as many of them as you like, and then finally provide what you're looking to log out, right? So what I prefer is going to be something different. So let's think about our interface and the API design and the features that we want out of this. So the first thing is we want styles to be persistent. And what I mean by that, if I apply red as the text color, I want for whatsoever logs, for like 10 different log statements following the point where I initialize it to be the red text color, I would want it to have the same text color until I manually decide I do not want it no more, right? I want to reset the styles. So that is one of the things I'm looking for. The second thing is, instead of having these chainable functions, uh, use, you know, let's say list of styles, right? So what a list or an array of styles allow us to do is, I feel it's more easily extendable. So you can have, let's say, a list of styles, then when you come across certain condition, you can add to that list, right? So let's say by default you have green color text. When you come across something important, you can add to that, base style of green color, and you can add bold or underline that text, right? So that's why having a list of styles versus these chainable function calls, I think would be more extensible and form a better API, right? So with those two things in mind, let's start designing out our API, right? So let's say if we want class, let's call it supercolor, right? So the first thing that I'm thinking of, we will have this styles variable, which is going to be this array of strings. So when I take in my constructor, I'm going to say, okay, my styles, when I initialize my supercolor class, it's going to be empty. Now, what are the different functions that I would like to have on this class? And as we are here, let's also make sure to export it so that we can utilize it. So as we are here, what do we want to implement? So one method is, let's say we say public log, which is going to take in some data and which is going to not return anything, just log it out, right? Another one is called, let's say we say set styles, right? So which takes in a list of styles and again does not do anything, but it is going to set those styles, taking that as input and setting our class variable as those styles. Another one is, let's say, would be reset. So this is going to just reset our set of styles. And then the last one, let's say, is going to be add style. So it's going to be, let's say, a little different from set style. It is going to append to the already existing list of styles, right? So all of them are not returning anything. They're just going to change and play around with the existing stuff. So what will add style do? It is going to say, let's say, so this dot styles will become this dot styles dot concat, I believe, and let's call in styles. Okay. Then reset will just say this dot styles is empty. Set styles, this dot styles would become equal to styles. So now the last one and the most important is the log function, right? So how we are going to log is we are going to use console.log, but how are we going to be adding color is using Ansi escape codes, right? So we cannot use the \033 because we need to be using the proper or equivalent escape character. So the equivalent of the \033 is, I believe, yeah. So escape character is 001B, right? So we'll use our 001B, and then we will have our square bracket. On top of that, we will have all the styles, right? So we will say this dot styles dot join with a semicolon, right? And then we will add an M at the end of it, and then we will have our data, right? So what we are doing here is we are saying, okay, I want to take my 033 square brackets, and then my styles will look something like 32, 42, 36, right? It is going to be an array of all the different styles that I want to implement or apply. So we are just going to concatenate all of those styles with a semicolon, right? And once we are done concatenating all of them with a semicolon, we will add the M at the end. And then after that, we will have the text that we want, right? So this is kind of the straightforward way of doing it. So now to test this code out, let's create an example file, and let's say, okay, we want to import supercolor, and then let's say instance. So this is our now instance. The first thing let's do is let's try to log it out. Hi there, right? Then let's say we want to set the style to be, let's say, so we want green font color, right? So we are going to set that style. Now again, let's log something and say, hi there with green text, right? Now let's set blue background to this, right? So let's add the style, and it is going to be blue background is 44, right? So now let's take another log statement and say with green text and blue background, right? Now let's try to see if a reset is working, and hi there after reset, right? So we have now a bunch of use cases that is testing out a different functionality of the code that we have just written. And instead of now turning our TypeScript code into JavaScript and then using Node to run it, we are going to use TS Node library to directly run the TypeScript code. So for that, we are going to say, okay, from my locally installed instance of TS Node library, I want to run source example.ts. So let's see what happens. Boom, right? So first log without any formatting, then we have this log with green text, then green text and blue background, and then finally we have, again, no formatting. So changes work like we would have wanted them to. So this is all good, right? Now thinking more, how can we make this better? Right now, the assumption that we are working under is the user is going to pass this array of string. So we are saying that the user would know that 32 corresponds to green text color and 44 corresponds to blue background color, and so on. But we do not want, or we should not have the users need to know this information to utilize our library, right? So what we are going to do is we are going to create a type that can better encapsulate and provide this information to the user. So let's say we create an enum called supercolor style, right? So what this is going to be is background black. So what is background black is 40, right? Similarly, we'll have a bunch of different styles that we are going to encapsulate in here. So black is 40, we have red, then green, yellow, blue. So we have 40, 41, 42, 43, 44, right? Again, I'm not going to be adding all of them, but let's also add a bunch of, foreground stuff. So let's just use the same set of colors instead of let's add foreground, right? And instead of them being 4, looks like they differ by 10. So let's just do this. Okay. So now we have created this enum that if the user says background black, it will correspond to 40. If the user says background green, it will correspond to 42, and so on and so forth. So now when I am, let's say, creating this set style, instead of passing 32, which is foreground green, what I can now pass is foreground green, right? And this is going to set my foreground to be green. Instead of passing 44, what I can again now pass instead is background blue, right? And what this should help us do is it should have the same effect on the output. Like our output should not change, but now we are not asking the user to memorize all these different codes. So this is good. So now what else can we do? So right now we are only looking at the 3-bit and 4-bit colors, but modern terminals can support 8-bit and also 24-bit outputs. So what is 8-bit is you have this array of colors starting at 0 until 255, where each number corresponds to some color that you can see in this graph. And what is 24-bit is you can provide RGB colors, right? So we also want the users to be able to utilize these functionalities if they want to. But before moving on to them, let us quickly also add a couple of other functionalities like bold and italics, right? So if you go up into this Ansi escape table, you'll see bold is N1, right? So to our supercolor style enum, we are going to add, okay, bold is this, and then some of the other things, let's say italic is 3, right? And then underline is 4. This depends, different terminals might or might not end up supporting it. So not every place, if you try to do an underline, you will see it happening. But these are some of the common ones that should be supported across most of the terminals, right? So if we quickly wanted to see, let's see, so add super color style dot bold. So let's see if that does anything. And as you can see, bold actually did work, right? So if you compare these two outputs, for the one with blue background, and the second one is actually that font is bold, right? So we can add pretty much all of these, different numeric values into our super color style, because this is a finite set, right? Now coming back to how do we represent these 8-bit styles, right? So for that, let's create a utility module where we will try to help the user create these styles. So let's say we create this function generate 8-bit style. Actually, let's say we say let's explicitly say we want a foreground. So the user will have some input, right? Because as you can see, the user will provide a number between 0 and 255 that we would end up using in this case as the foreground color. So what we are going to do, kind of the corresponding Ansi escape value for this would look like, so 38 corresponds to foreground, and then you have 5 that corresponds to that. We want to, you know, refer to 8-bit numbers, right? And then finally to this, we will add the user's input, right? We also want to make sure that the input is valid, right? Because the number should be between 0 and 255. So let's create a small function here, which is going to say if my input is less than 0 or my input is greater than 255, I'm going to throw an error saying that incorrect input to generate style, right? So here let's just call is valid input on the incoming value, and this should make sure that whatever we are responding with is good, right? Similarly, if we want an 8-bit background, let's create another function for that. An 8-bit background will use 48 instead of that, right? We can possibly refactor the generate 8-bit background and 8-bit foreground functions. Actually, let's do that maybe, yeah. So let's say we have a function generate 8-bit style. So this will take as an input number, and it will take in let's say type, or it's a style type, which is going to be either background or foreground, right? So, and then this will return, so if style type is background, if style type is background, I want to return this, else I would like to return we should also make sure we are doing this. Right, so now let's refactor it out. Input and then foreground, and then return input with the background. Okay, so now let's say if we wanted to test this out, let's go back to our example. So that's a supercolor.setStyle generate okay, yeah, generate 8-bit foreground, and let's say what color do I want for my text. Let's say 105, right? And then let's log something out, testing 8-bit style. Let's see. So as you can see, it is different color. Actually, let me change it so that it's more visible. But I do see the difference. Okay, yeah. So as you can see, testing 8-bit style, there we have it. Now, what else? Okay, so moving on to 24-bit. So what does 24-bit color space allows us to do is specify a red, green, and a blue value, a value in the RGB color space. So how we would go about doing that? So just like we had this generate 8-bit style, let's say we have generate 24-bit style, and it will validate. So my input first of all is going to be a tuple with R, G, and B values, and I'm going to be validating if each of my RGB values are within 0 and 255, right? So once I've validated that, what I'm going to do is, let's say, yeah. So once I've validated my inputs, now I have to construct this RGB value, right? And that will look like, so const calculated style. It will look like my R. Oops. So this is my R. And then I will add it with a semicolon. So I'm basically trying to follow the pattern that we have here, right? So we have our R semicolon followed by a G, and then this will be followed by the B value, right? And then calculated style, and this is no longer going to be 5, because 5 was when we were thinking about or talking in 8-bit space. This is going to be 2, which will signify the fact that we are talking in 24-bit space. And then finally, let's create similar functions and say, okay, now generate 24-bit, and then my input type is going to look a little different, and then the helper I'm going to call is going to look a little different. Okay, so now I have this RGB color space functions. So now to finally test this one out, let's say supercolor dot reset, and then supercolor dot, actually let's not do reset, let's try to use supercolor dot set style and see if it basically resets and also sets the style. So now we want to RGB color space check, color space map, let's say. I quickly want to get some values. So maroon is 128, 0 and 0, right? So let's try to get generate 8-bit, generate 24-bit foreground, and for maroon it is going to be what was it, 128, 0, 0. Now let's say, okay, now we are testing 24-bit style, and let's also try to have some background. So I'm struggling to pick a color. Let's go with khaki. So So generate 24-bit background. So khaki is 240, 230, 140. Oh, this should be an array. Okay. Fingers crossed. Okay. So we have our khaki background with maroon text. So I think that encapsulates all. Uh, One other thing to be kind of mindful of is, again, not all terminals, as I indicated, support all the different or 8-bit as well as 24-bit color spaces. So you should make sure that your terminal is able to support that. One good way of doing so is checking for the color term environment variable. So if I say echo color term, so as you can see in my terminal, I get true color, which basically is another way of saying that it supports that RGB color space. So you should also do the same thing in your terminal to make sure that your terminal does support it. Another way of doing the same is using this command dput colors. So that again says 256, which indicates that, okay, my terminal supports this wide array of color spaces. So with that, I think this is all. I will be uploading the code and pushing it onto GitHub. I would be making maybe a few changes and adding some of the more uh, numerical spaces and comments and things like that. But as far as the feature set goes, I think this is good enough for now. So hopefully it was helpful. And feel free to leave comments, like the video, and subscribe. Thank you.